In the year 2026, web development sits at a pivotal nexus where the strategies for user experience, search engine optimization, and technical architecture converge. To create a high-performance web application that dominates the search landscape, one must analyze not only the user-facing aspects of design, but also how content is discovered and processed by automated agents, the search engine crawlers. The dilemma of JavaScript rendering and its implications on indexability reflect one of the most profound shifts in web development paradigms of the decade. The search engine's dual-phase indexing pipeline comprises an initial HTML scan followed by an asynchronous, comparatively delayed rendering of in-page JavaScript. For a technologist, this means that the difference between being visible and invisible to search is measured in the critical seconds or days it takes for JavaScript to execute and expose content. This so-called rendering gap introduces a tactical disadvantage, particularly in competitive sectors where the speed of discovery dictates outcomes. This context sets the foundation for the perennial debate between server-side rendering (SSR) and client-side rendering (CSR). In a classical CSR architecture, JavaScript is king. The browser loads a minimal HTML shell and then populates the interface via JS execution. For users with state-of-the-art browsers and connections, the approach promises seamless interaction after bootstrapping. However, for crawlers, this strategy can present an opaque, minimal document, an unattractive prospect for timely indexation. SSR, on the other hand, precomputes user-facing HTML on the server. The crawler is greeted with a fully realized document, rich with content, metadata, and semantic structure. In an era of core web vitals and user-centered signals, SSR provides a pragmatic, SEO-aligned starting point, but can often increase load on back-end infrastructure and complicate dynamic interaction. Enter the hybrid paradigm, hydration. Here, SSR is used to deliver complete, crawlable content, and then client-side JavaScript hydrates the page, attaching events and interactivity, thereby marrying the discoverability of SSR with the fluidity of CSR. Modern frameworks, such as Next.js or Astro, have made this approach the industry benchmark for both SEO and user experience. The technical conversation then focuses on Google's core web vitals, CWV largest contentful paint, LCP, first input delay, FID, and cumulative layout shift, CLS. LCP is enhanced through the strategic use of server rendering and deployment of lazy loading for non-critical assets. FID is minimized when interactivity is prioritized. By hydrating only critical portions of the page, developers reduce perceptual lag. CLS is controlled meticulously by serving critical CSS and reserving space for images or advertisements to prevent disruptive reflows. Here, architecture decisions exert a direct influence on ranking signals, moving web performance from an aesthetic concern to a quantifiable competitive advantage. The crawl budget compounds these concerns. Every site receives a finite allocation of crawler attention, governed by site authority and processing costs imposed by complex JavaScript. Excessive client-side computation can bottleneck the crawler, causing deep content to be left unexplored. Analytical tools, prominently Chrome UX reports, diagnose rendering bottlenecks so that developers can audit and refine their pages, delivering HTML that is lean, direct, and comprehensible. For legacy systems or inherently dynamic SBAs, dynamic rendering emerges as a strategic detour. Middleware intercepts requests, distinguishing between bots and humans. Crawlers are served a simplified, pre-rendered HTML snapshot, while end users receive the high-fidelity, interactive interface. Though sometimes dismissed as a transitional solution, dynamic rendering ensures search equity remains intact even as aesthetic ambitions and legacy constraints challenge technical orthodoxy. In conclusion, the architecture of web applications in 2026 must be built on a deliberate rendering strategy, harmonizing SSR, hydration, and tactical optimizations for CWV. By understanding and engineering the critical rendering path, tuning for search engine limitations, and strategically balancing interactivity with indexability, development teams secure both visibility and relevance in a search-driven future.